Unit 1, Lesson 2, Properties of Matter. In this part of the book, the lesson is all about what is the difference between a physical and chemical property. So on page 23 of your textbook, you have a section called Engage Your Brain. This is to find out what you know right now about the content. So having a wrong answer isn't necessarily a bad thing. So don't worry about getting the answer right or wrong. Just put what you know right now. So pause the video, complete page 23, and then come back to the video when you're ready. So the first 4 questions are, liquid water freezes at the same temperature at which ice melts, and this is true. A bowling ball weighs less than a styrofoam ball of the same size. Hopefully, you mark that one false. An object with a density greater than the density of water will float in water. If you remember back from our last lesson, we talked about density and that things in water will float if their density is less than water. The density of water is 1 gram per cubic centimeter. And so this statement is false because if it's greater than 1, that object is going to sink. And the last statement, solubility is the ability of one substance to dissolve another. And that is true. The first type of property that we're going to talk about is a physical property. So we're going to talk about what are the different types of physical properties that we can encounter. So you should be following along in your textbook, which is your guided notes for this part. And you have the definition of a physical property. Vocabulary is very important, so I would suggest that you highlight this definition on page 24. So this is something that we can observe without changing the object. Let's see, let me find something. Okay, so here I have a flash drive that looks like Fred Flintstone. So that would be a physical characteristic. I can separate pieces of it. That would be a physical characteristic. It's soft to the touch. It has the colors orange and blue in it. It's probably insoluble in water. So those would all be physical properties, not insoluble in water. Sorry, that would be a chemical property. So scratch that one. Okay, so here we go. As you're reading on page 24, it talks about gold. And so I want you to go to the last page of this section, and it's page 38. And I want you to list some properties of gold. And so as you're putting things back on that back page as we go along, it's a good idea to give it a title and maybe the page number it's on, so that when you're reviewing for the unit or quiz or master check, you can easily understand what that is. So after you read the information on page 24, you have a describe prompt. And this describe prompt says, does observing a physical property of a substance change the identity of the substance? So first you got to say yes or no, and then you need to explain why you chose yes or no. Make sure to use science words as much as you can. So here I have some Play-Doh, and some physical properties of the Play-Doh would be it's yellow, it smells doughy, it's squishy, it's soft, it's sticky. So all of those would be physical properties, things I can observe, and I haven't changed it. It's still going to be Play-Doh. Then you go on to page 25 and you read some more, and you have a visualize it prompt. And this says that you should describe the physical properties of the object that you see in this photo. So if you're using your 3-ring binder, you might want to take these 2 pages out and put them together so you can look at the photo more closely. So in this photo, the thing that's happening is gold is being melted. So you ought to be able to say something about the container that the gold is in, the gold itself, and something about boiling and melting points maybe. Then on the bottom of page 25, you have a think outside of the box question. You have a paper to fill out to help you answer this, and it should be in your Unit 1 packet of handouts. And it asks you to describe a common object by naming its properties. So this is kind of like playing I Spy, except for you're writing down the clues first. So after you write down the clues, trade your mystery object page with a classmate. Take theirs and see if you can figure out what their object is based on their clues. At the bottom of the paper, it has a place for you to reflect. We are going to talk about density a lot through this semester when we're talking about chemistry, properties of matter, elements, and that sort of thing. So right now we're on page 26 of your textbook. So I had this slide, I forgot. Remember that things that are less than water float in water, things that have a density more than water sink in water. Some things that you can infer based on these pictures is in the top left. You can infer that the liquid being added is less dense than the liquid it's being put in. Now we can also infer that it's water and oil, but that's an inference unless we know for sure. And then in the column on the bottom, we have 2 objects. We have the red circle, and then we have the white circle. And so we know that the red circle has a density greater than the white liquid and a density less than, sorry, I should have said less than the white liquid at a density greater than the red liquid. Because it's floating above the white liquid, which means its density is less than the white liquid, and it's below the red liquid. Question number 8 on page 26 asks you to look at the photo and talk about the density and the characteristics of the things that you see in the video. So pause the video, come back when you're ready. So the things that we could say is that since the oil is the top layer, that it's less dense than the vinegar. And we know that the vinegar, since it's the bottom layer, has to be more dense than the oil. The next physical characteristic that your book talks about is electrical conductivity. And that's how well a current can go through a substance. We have 2 types of substances that we'll talk about later on. One is a conductor. That means it easily transmits electrical current or heat. And those examples would be metals. So if I had a metal ladle and putting it in the soup and I held on it and left it in the soup, the ladle is eventually going to get just as hot as the soup because the metal is a good conductor. But I know that if I go and get my oven mitt, which would be an insulator, meaning it doesn't conduct electricity very well, and I hold on to that ladle, that the oven mitt is going to help protect me from that conduction of heat through the ladle. In this example on the slide, you can see that before the person added the substance, that the light bulb didn't turn on. But when he added the substance, the water became able to conduct electricity and able to light the light bulb. The next property is thermal conductivity, and we kind of talked about that in the last slide. And that's the ability of a substance to transfer heat. In this race car, it's probably going to be very important that the heat of the engine is pushed away from the driver. Solubility is the next physical characteristic that we're going to look at. The new thing in laundry is that you can get laundry sheets that dissolve as you're washing your laundry. Instead of throwing in a Tide Pod that has that plastic in it and that kids can swallow, you could throw in this sheet into your laundry and it dissolves as your laundry is being processed. And so you're not really left with anything, and kids probably aren't going to choke on this sheet. So question number 9 on page 26 asks you to predict what would happen if you made some Kool-Aid, stirred it up, and then left it outside for a couple of days. So pause the video, answer the question, and come back when you're ready. So the next physical characteristic is malleability. And so it's the ability of a substance to be pounded or shaped into a different shape. So with my Play-Doh is very malleable. I can squeeze it and it's going to change the shape and take the form that I want it to. Same thing with aluminum foil. Same thing with a wire that's in this pipe cleaner. I can twist it and it very easily changes to the shape that I twisted it to. Now, other things like this wooden block, I'm pushing on it as hard as I can, and I am not able to change the shape of this wooden block. So it would not really have the property of being malleable because I can't really squeeze it and push it to change its shape. Now, could I hit it with a hammer and probably split it into several pieces? Yes. But we're talking about being able to easily change it and change its shape. So aluminum foil is an example of a metal that has high malleability. Gold also is considered a soft metal in that it's very malleable. Okay, question number 10 on page 27. It asks you to name something made of aluminum and explain why malleable is useful to its property. To think about in your life, in your everyday life, how you might come in contact with aluminum. We've made something to take advantage of this property of aluminum being very malleable. So take some time, answer the question, pause the video, and come back when you're ready. Luster is just a fancy way to describe the kind of shininess an object has. So the lid of my Play-Doh is shiny, but it has a different shininess than the top of my lipstick container. And we actually wear lip gloss because of its luster ability, its ability to shine and reflect light. My notepad has a luster, but it's not considered a shiny luster. It'd be considered a dull luster. Magnetic attraction. So we all know about magnets, that if we take the positive in and we put the positive in next of another one next to it, that it's going to repel. And we know if they take the positive and the negative in and put them together, that they're going to attract. So some metals, some rocks, will have this ability to attract things based on these positive and negative charges. Another physical property is a melting point, and that's the point at which a substance will change from a solid to a liquid. And you can see the person that has their hand open has a special type of metal, and I think it's galadium, that the melting point is so low that it can melt in your hands. And you can see in the picture up at the top that the ice is melting. An opposite of melting point is boiling point. And so I want you to write this definition in this area underneath the picture of the magnet so that you'll have that definition ready for when you're ready to study. So pause the video, write down that definition, and then come back. And that definition has to do with your next question, number 10. Number 10 asks you to infer by comparing what happens when a geyser erupts to when a tea kettle whistles. Usually here in America, we don't drink a lot of tea, but over in Europe they do. And so they put their tea on the stove and it heats up the water in the tea kettle. And when the water is hot enough, the air gets forced out the spout of the tea kettle and it makes a whistling sound to let them know that the water is ready. So make sure to use some science words that you've learned so far. And I think, yep, that is the end of this set of slide explanations.